Hello and welcome to this video. Today I will show you the new all-in-one HF reader TAS Q130 with multiprotocol functionality. I will show you in TAS how to set up and configure the reader. You already know the U interface in the TBN family. Here we have the same functionality built into this reader, and I will show you also a very important new website and functionality in combination with TAS and this reader, which gives an indication to the user how high is the influence of metal in the application, and you can see also an RSSI value, which also gives an indication how good is the combination working in the application. Here we see the Turck automation suite, the TAS website. On this website we see the connected devices, or we can scan the network for connected devices, or we can add devices manually. We see here the new TAS Q130, the new all-in-one HF reader with multi-protocol functionality. And by clicking on the IP address, we will be asked if we want to open the TAS website or the device-specific website. Today we go into TAS. And here we see our information for the HF reader. For example, type code, the ident number, IP address, and very important, the firmware version of this device. On the left side, we see some information. We can get a parameter, for example. Here we can see and change the network-specific information, for example, for Modbus TCP, for Ethernet IP, or for Profibus. We can change, for example, the device name and do other settings here. Now we go to the local I/O, which means HF functionality. We see here the parameter, and if I want to change some parameters here, first I have to log into. And now I can choose different settings. In general, it looks quite the same as the U interface in the TBN family. So we have here the two main basic functionalities, HF compact and HF extended. The main difference between these two functions is that we can read and write more data with the HF extended mode. We also can see here the bypass time. The default value is 200 milliseconds, for example, and see all the other things which I need to know. I also have diagnosis information, for example, how long a tag was in front of the reader, how many milliseconds, and we can go to the input buffer of the reader. And here we can see, for example, if a tag is in front of the reader or not. If we place now a tag in front of the reader, I can see that this value has been changed, and I can see right away the UID in the input buffer here. We go to the output buffer, and also here I can see the input values, which I have seen before, and also the output buffer if I want to write information to a tag. And on the top we can see there is a button called RFID reader. We can click on it and we can see here a scanned tag. So we see the tag information but important is the HF quality here. Here we see two main things. One is the influence of metal to the reader, the HF quality, and we see an RSSI value, which means the strength of the check signal to the reader. And if we place metal to the side of the reader, then we see this bar graph is changing. Sorry, I have to click on Start first. And if we place now metal to the reader, we see that this bar graph has some information, and we see the influence is quite low. If we now place the metal on the top of the reader, we see that the influence of metal is much higher, but it is even in the green, so which means it's still okay. And if we place now metal to the front and go closer, and then we see that the antenna of the reader is detuned due to the metal, which gives an indication to the user that he has to increase the distance from the reader to metal. The other value is the RSSI value. And if we place a tag in front of the reader, we see the tag present signal, and we see here the RSSI value. And we see the rising of the RSSI value if we go closer to the reader, and how it is falling if we go away from the reader. And this gives an indication to the user how good is my tag reader combination in an application.